Okay, so we're gonna do some implicit differentiation. Okay, so you already know how to find a derivative of an equation like this. It's the most easiest thing ever. It's just no-brainer. You don't even have to think about it. Just super fast. Boom. Answer done. So use your derivative rules and figure it out. But when you're doing this, you're actually skipping a step in the middle. All right, so you have your equation, and then when you find the derivative, you end up having dy on one side and dx's on the other side. And then you end up dividing both sides by dx, and that's how you get your final answer. Dy over dx equals 3x squared plus 4x minus 5. And so you're actually skipping that middle step of writing out all the dy's and dx's. And the reason you can do this is because when you have an equation like y equals something with only x's, so then this equation's so simple that the middle step kind of solves itself. It kind of happens naturally. So you don't even have to worry about it because you just have like a y on one side and all x's on the other side. So you don't even have to worry about this middle step. However, when you have an equation like this, where you have y's and x's on the same side, and they're all like to like not the first power, they're all to like the third power, second power, any power, then you can't skip that middle step anymore. You have to use implicit differentiation, and all that really means is that you're doing the same thing as you did before, except now you don't skip that middle step. You have to write out all the dy's and dx's. So let's go ahead and do that. See, there you go. You got all your dy's, you got all your dx's written out. For each variable, there should be a dy and a dx when you find the derivative. That's important to remember. And the derivative of 56 is just 0. And so, now, we're not done yet. We gotta remember, our end goal is to have dy over dx equals something. Whenever you find the derivative of an equation, that's always going to be your end goal. So it's important to remember that that's your end goal. So all we have to do is just do some algebra. We got to rearrange this so we end up with dy over dx equals something. So first, we would factor out the dy's and dx's. So there we go. Now it's starting to make a little bit more sense. This equation is starting to be a lot cleaner. You can start to figure out your course of action to getting dy over dx by itself on one side. So next thing you would do is you divide both sides by dx. There you go. Now you even have your dy or dx. And then it's easy. This is easy to do because 0 divided by dx is still just 0. So this works out well. So now you have your dy over dx. You just got to do some simple algebra and just get that by itself on one side. So boom, subtract both sides by negative 12x plus 1. Divide both sides by 3y squared plus 4y. And there's your final answer. Dy over dx equals negative 12x plus 1 over 3y squared plus 4y. So it doesn't matter that your answer has x's and y's on one side because the other side is just dy over dx. So it doesn't really matter what your answer is as long as you have dy over dx by itself on one side. So implicit differentiation is pretty similar to normal differentiation. You just got to remember to not skip that middle step. You have to write down all the dy's, dx's. And once you do that, then you just do some algebra. You got to rearrange it so you get dy over dx equals something. So yeah, there you go. That's implicit differentiation. It's not actually that hard.